In this video, you will learn how to multiply fractions. And when we're multiplying fractions in this lesson, we are doing this in the context of algebra. So it's not just a simple fraction of like 2/3 times 4/5, but now we're going to incorporate algebraic expressions within the fractions. Now, when we simplify and multiply fractions together, all the rules of fractions will still apply. So when you're multiplying fractions, remember that if you have a over b times c over d, I multiply the numerator together, so we get a times c, and then I multiply the denominators together to get b times d. So in other words, you're just going to multiply the tops and multiply the bottoms together. So with actual numbers, if we had 2 over 3 times 4 over 5, I would multiply the 2 times 4 on the top and the 3 times 5 on the bottom to get 8 over 15. Now, with fractions, when you're multiplying, there are times when I will need to simplify as well. So for example, we have 5 over 9 times 27 over 10. Alright, so when I'm simplifying and multiplying numbers together, I can either multiply first and then simplify, or simplify first and then multiply. So here, we're going to multiply first and then simplify. When we multiply first, we have 5 times 27 over 9 times 10, which would give me 135 over 90. And I can divide top and bottom by 5, which would give me 27 over 18. And then I can take that further and divide by 9 to get 3 over 2. So notice when you multiply first, many times you're going to get large numbers that you need to work with. But it's going to be easier typically if we simplify first and then multiply. So using the same example, when I simplify first, I can imagine this fraction bar being extended. And so now anything in the numerator can divide with anything in the denominator. So I see here the 5 and the 10. I can divide both by 5 to get 1 over 2. And then the 27 and 9 can divide out, and that would give me 3 and a 1. So I've simplified first, and now from here I can multiply. So now I'm multiplying 1 times 3 to get 3, and then 1 times 2 on the bottom to get 2. Notice the second way of simplifying first and then multiplying is much easier to work with typically. And as we proceed, we will use this second method to simplify. So here is another example, but now we're going to throw in some variables. So right here we have 6xy over b to the third times b over 3y to the fourth. Remember, I can imagine this line being extended so that anything in the top can divide with anything in the bottom. So I see the 6 and the 3, those can divide to get 2 and 1. Alright, and then the y's, I can divide those out. When we divide those, I'm going to be left with y to the third on the bottom. Right, I subtract the exponents, 4 minus 1 to get 3. So y to the third is in the bottom. And then looking at the b's, b and b to the third, those can divide out, and I'm left with the b squared on the bottom. So what I have left is a 2 and x in the top, so we have 2 times x. In the bottom, we have b squared times y to the third. So my answer is 2x over b squared times y to the third. Example 4. Now we're going to be throwing in a little more difficulty. Now here we have not just variables, but we have also some binomials thrown in there. But same exact concept. So I can imagine this line being extended right here, and so anything in the top can divide with anything in the bottom. So look at the top, we have x right here and an x over here. So we have x times x, which is x squared. That can divide with the x to the third power in the bottom. X squared divided by x to the third would give me 1 over x. So we have 1's on the top and then x on the bottom. And then looking at the x minus 3's, we have 1x minus 3 on the top, 2 on the bottom. So when I divide those out, I'm left with 1 over x minus 3. And then the 2x plus 5s, we have 2 on the top and then 1 on the bottom. Those can divide out, and that leaves me with 2x plus 5 on the top. So now on the top I have 1 times 2x plus 5 times 1, which would just be 2x plus 5. And on the bottom we have x times x minus 3. So this right here would be my solution. Example 5. Similar to the last one, we have y plus 3 to the third power over 3y minus 1 times 3y minus 1 over y plus 3. Looking at the y plus 3's on the top and bottom, I can divide those, and I would be left with y plus 3 squared on the top and 1 on the bottom. Right, because we have 3 of these on the top, 1 on the bottom. When I divide out, subtract the exponents 3 minus 1 to give me 2 on the top. And then the 3y minus 1's can cancel, and that gives me 1 over 1. So my final answer is y plus 3 squared over 1, which is just y plus 3 squared. Now, if it's not factored already, such as this example, I will need a factor first before I can start dividing things out and simplifying. So at this point, I need to factor the x squared minus 1. So if I do that, I'm going to get x minus 1 times x plus 1. That's a difference of squares. This is x minus 1 times x plus 1. And the bottom we have x minus 1. And then times 2x squared minus 5x plus 2. That can factor. And I'm going to have, let's put this away for a second. We're going to have 2x and then x. So that would give me 2x squared. And then to get the 2 for the last term, we would do 2 times 1. So if I put the 2 here and the 1 here, make them both negative, that would multiply to give me a positive 2. And we would get negative 5x back out for the middle term, because negative 1x, and then negative 4x would give me negative 5x. And then for the bottom of that second fraction, that is actually a difference of squares. We have a 2x being squared, so we put 2x here and here, and then minus a 1 being squared, so put a 1 there and there, make 1 plus and 1 minus. So we have factored, and now from here we can start dividing things out. So we see an x minus 1 on the top and an x minus 1 on the bottom. Those can divide out. We see a 2x minus 1 on the top and a 2x minus 1 on the bottom. Those divide out. So what I'm left with is this x plus 1 on the top times this x minus 2 on the top, divided by, and then we have 2x plus 1 on the bottom. So this would be my solution. Now as we finish, let me remind you of our rule of exponents for a power of a quotient. And that says if we have a fraction raised to some power, then we raise the numerator to that power as well as the denominator to that power. So for example, if we had a over 2 and then raise that to the 4th power, what that means is that we have a to the 4th power divided by 2 to the 4th power. And 2 to the 4th power is 2 times 2 times 2 times 2, which would be 16. So that answer would be a to the 4th divided by 16. Let's look at one more example using this rule that we've just described. So here we have negative a over 3 squared times 6 over a to the 4th power. So what this means is that we are going to raise both the numerator and denominator to the 2nd power. We have a negative number raised to the 2nd power, which means we have negative times negative, which would be a positive number, right? So our answer for this part will be positive. And then we have a squared, so that's a squared, over then the 3 squared, which would give me 9. So we have a squared over 9 times 6 over a to the 4th power. Alright, so from here the 6 and the 9 can divide both by 3. We're going to have 2 and 3. And then the a squared and a to the 4th power can divide out. When I divide, I subtract the exponents, 4 minus 2 to get 2, and that 2 is going to go in the bottom because the 4 was bigger and that was in the bottom. So what I have is going to be a 2 on the top, and then 3 times a squared on the bottom. So this would be my solution.